We're at a point in science finally where we understand how cells in the human body works well enough that we can now not only understand which genes might be causing disease in people, we have ways to correct those genes, and maybe most importantly, we have figured out how we can control cells and change them into almost any different cell type that we want to try to help repair organs. And in our case, we're obviously most interested in repairing hearts that have been broken, either at birth or when people get older and have suffered heart attacks. It certainly was the dream after years of taking care of children who were born with heart defects, and we had almost nothing we could do for them other than change their plumbing, which helps a lot, but we weren't getting at the crux of the problem. And the same thing is true for adults with heart disease. We can give them medicines, but we don't get to the fundamental problem, which is most of the time they've lost heart cells and they just need more heart cells. And now I think for the first time we at least can see the light at the end of the tunnel where we can create new muscle cells for those who have lost them.
I really want to understand all of the switches that make a heart cell. That's my curiosity-driven motivation, is to really understand that. But more long-term and more focused on disease, I'd like to understand congenital heart disease well enough that we can develop a preventative therapy, like something that a pregnant mother could take that would help ensure that a child is not born with a congenital heart defect. The other thing that's amazing that's happening in Deepak Srivastawa's lab is being able to take just a handful of factors and turning a skin cell or a fibroblast cell from the heart into a new beating heart cell and regenerating the mouse heart that way. It seems like science fiction, and yet it's surprisingly easy. You can take skin cells from somebody with a particular disease and then turn them into iPS cells and then turn them into heart cells, and then you've got the exact genetic makeup that that person had. Tanya's been working with me or near me for, I guess, the last 9 years, and so it's been really great to have her not just as a life partner but as a colleague here. She has this knack for working with stem cells. She has this magic touch that makes things just work.